What specific problem does the ReasonIR 8B method aim to solve in the context of reasoning-intensive retrieval, and how does it differ from traditional retrieval approaches?
The ReasonIR 8B method specifically aims to address the challenges of reasoning-intensive retrieval, which involves retrieving documents that require complex reasoning rather than straightforward factual answers. Traditional retrieval approaches typically focus on short, factual queries that can be matched directly to relevant documents, often resulting in poor performance on longer, more complex queries that characterize reasoning tasks. In contrast, ReasonIR 8B utilizes a novel training approach through ReasonIR synthesizer, which generates varied-length queries and hard queries based on real documents, along with hard negatives that are specifically designed to be misleading yet superficially relevant. This synthetic data generation allows ReasonIR 8B to better handle the low lexical and semantic overlap often found in reasoning-intensive queries, thereby improving retrieval quality. Ultimately, ReasonIR 8B achieves state-of-the-art performance on reasoning-intensive benchmarks by leveraging this tailored training data and enhancing the effective context length for queries, distinguishing it from traditional retrieval methods that are ill-equipped for such tasks.
How does the proposed ReasonIR 8B algorithm work? Illustrate the methodology step by step, including the role of ReasonIR synthesizer in data generation and training.
The proposed ReasonIR 8B algorithm operates through a systematic methodology aimed at enhancing reasoning-intensive retrieval. First, it utilizes ReasonIR synthesizer to generate synthetic training data, which includes two main types: varied-length queries paired with synthesized documents to extend the effective context length, and hard queries derived from real seed documents to challenge the retriever. The hard queries are generated using a human-like brainstorm guideline to ensure they are diverse, self-contained, and demanding in terms of reasoning. Next, our ReasonIR 8B is trained by fine-tuning the Llama 3 1-8B model on a combination of public datasets and the synthetic data produced by ReasonIR synthesizer, employing a contrastive learning objective to optimize the retrieval quality. Finally, the algorithm is evaluated on reasoning-intensive benchmarks, demonstrating state-of-the-art performance by effectively leveraging the rich information from longer, rewritten queries and integrating with LLM re-rankers for improved retrieval outcomes.
Can you provide a simple yet illustrative example of the inner workings of the ReasonIR 8B algorithm? Walk through the key steps using an example of a reasoning-intensive query and its retrieval process.
The ReasonIR 8B algorithm operates through a series of key steps designed to enhance reasoning-intensive retrieval. For instance, consider a reasoning-intensive query like, how does the concept of opportunity cost apply in economic decision-making? First, the algorithm utilizes the ReasonIR synthesizer to generate a varied-length query and a corresponding positive document that provides relevant background information on opportunity cost. Next, during the retrieval process, ReasonIR 8B encodes this query and potential documents as vector embeddings to compute cosine similarity scores, identifying the most relevant documents. Importantly, it also generates hard negatives, documents that superficially seem relevant but do not aid in answering the query, using a multi-turn approach to ensure the training data is challenging. Finally, the algorithm employs a query rewriting technique to refine the initial query, enhancing its detail and informativeness, which further improves the retrieval quality and relevance of the documents retrieved.
What are the theoretical or practical advantages of using ReasonIR 8B compared to existing retrieval methods, particularly regarding its performance on reasoning-intensive tasks?
ReasonIR 8B offers significant theoretical and practical advantages over existing retrieval methods, particularly in its performance on reasoning-intensive tasks. Firstly, it is specifically designed for reasoning-intensive retrieval, utilizing the ReasonIR synthesizer to generate challenging training data that includes varied length queries and hard negatives, which existing retrievers struggle with due to their focus on short factual queries. This tailored training approach allows ReasonIR-8B to achieve state-of-the-art results on benchmarks like Bright, with NDCG at 10 scores of 24, 4 for original queries and 29, 9 for rewritten queries, outperforming other retrievers while requiring significantly less computational resources. Additionally, ReasonIR-8B benefits from query rewriting, which enhances retrieval quality by allowing longer, more informative queries, a feature that other retrievers do not leverage effectively. Finally, its ability to integrate with LLM re-rankers further improves its performance, demonstrating its adaptability and efficiency in handling complex reasoning tasks.
How is the ReasonIR-8B method validated or tested? Describe the experimental design, datasets utilized, and the performance metrics employed to demonstrate its effectiveness.
The ReasonIR-8B method was validated through a series of experiments using both reasoning-intensive information retrieval (IR) and retrieval-augmented generation (RAG) benchmarks, specifically the Bright, MMLU, and GPQA datasets. The experimental design involved fine-tuning the ReasonIR-8B model on a combination of public datasets and synthetic data generated by the ReasonIR synthesizer, which included varied length queries and hard queries. Performance metrics employed to demonstrate effectiveness included the normalized discounted cumulative gain at rank 10, NDCG at 10, where ReasonIR-8B achieved state-of-the-art scores of 24, 4 on original queries and 29, 9 on rewritten queries in Bright, as well as significant relative gains of 6, 39% and 22.58% on MMLU and GPQA, respectively. Additionally, the model's performance was compared against existing retrievers and LLM re-rankers, showcasing its superior efficiency with over 56% less compute required than traditional LLM re-rankers. The results indicate that ReasonIR-8B effectively improves retrieval quality for reasoning-intensive tasks.
What specific results were achieved with ReasonIR-8B on reasoning-intensive retrieval tasks? Highlight any state-of-the-art performance metrics and comparisons to other models.
ReasonIR-8B achieved state-of-the-art results on the Bright benchmark for reasoning-intensive retrieval, with an NDCG at 10 score of 24. 4 using original queries, which improved to 29, 9 with GPT-4 rewritten queries, and reached 36, 9 when combined with an LLM re-ranker. In comparison to other models, ReasonIR-8B outperformed recent LLM re-ranker baselines, while requiring over 56% less computational resources. Additionally, on reasoning-intensive RAG tasks, ReasonIR-8B demonstrated relative gains of 6, 39% on MMLU and 22, 58% on GPQA compared to closed-book baselines, surpassing other retriever and search engine baselines. These results highlight the effectiveness of ReasonIR-8B in handling complex reasoning tasks, showcasing its superior retrieval quality and efficiency.